Hello Ninja Warriors, welcome to yet another power packed and most awaited session where I'll be discussing most expected questions for your midterm examination which will be lying under the category of 5 marks. Okay. Alright, so this is gonna be a mathematics session, as you all know that I teach mathematics. And before I start and dive into today's session, here is one very important tip that you guys not only just watch the session, but you are going to solve each and every question with me in your notebook, because if you only just watch it, you will understand everything, but when it comes to writing exact answer in your upcoming examination, you won't be able to get full marks in that particular question. So highly recommended that you have to solve it in your notebook so as to get a maximum from this session. On this note, I will introduce myself. So for all of those who are new to the channel, who are new to the session also, this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience in both online and offline, and I have taught various students who has got selected in various IITs, NITs and various other colleges as well. Alright, so now is the time that we should start with all the questions tuck without wasting any time. So the very first question is from the chapter functions. Okay, so the question says, and this is going to be 5-mark question, right? So the question says, let there is a function which is defined from n to y. Here n is natural number and y is some set which they are defining in the question only. So f is a function from n to y, which is a function defined as fx equals to 4x plus 3, where capital Y, this set they are defining it over here, capital Y will be a natural number which will satisfy y is equals to 4x plus 3 condition for some x belongs to natural number. Now, what we need to do, so they have given the information, but what exactly you have to do is here they are telling. First of all, we need to show that the function is invertible, that is our first job. And the second is find the inverse of f. Okay, alright. So we need to understand that we need to write all the steps in detail, beautifully, neat and clean, so that we can get full marks for such questions. Okay, so I'll show you how to write this question, how to solve this question. First of all, we need to show that f is invertible. We need to work on this first, and then after we are done with this, we have to work on this. Clear? For a function to be an invertible function, let me just write down. Okay, let me just change the color. Alright. For a function to be invertible, that function has to be 1, 1 and on 2. For a function to be invertible, it has to be 1, 1, 1, 1 and on 2. Right? 1, 1 and on 2. So that means we have to prove that my function is 1, 1 as well as on 2. Okay. Now let us talk about only 1, 1 part. Okay, one by one. So 1, 1. For a function to be 1, 1, how to check whether a function is 1, 1 or not? So what we need to do is, we need to take two values x1 and x2 being natural numbers. So what I am trying to do is, in this function fx equals to 4x plus 3, I am going to put two different values which are natural number. Obviously, we can only put natural number. It is given in the question. So only natural number. x1 is first natural number and x2 is second natural number, right? So now f of x1 should be equals to f of x2. Right? We need to understand what condition we are getting by equating f of x1 and f of x2. Now we know f of x1 will be what? So f of x1 will be 4x1 plus 3. So I am just putting x1 in place of x so that I will get f of x1. And now f of x2 will be simply 4x2 plus 3. Now we need to solve this. We need to understand what the condition we are getting. So 4x1 plus 3 is equals to 4x plus 3. If I solve it, 3 I have to cancel, right? Then 4x1 is equals to 4x2. This implies x1 equals to x2. Okay, ma'am. That means f of x1 equals to f of x2 implies x1 equals to x2. Therefore, hence, oh, what has happened? Hold on. This I did not write. This came out of nowhere. Okay. So if I equate f of x1 and f of x2 and I get only this condition, which is x1 equals to x2, that means the function, therefore, the function is 1, function, my dear students. 1. The function is 1. So this part, for a function to be invertible, it has to be 1 and onto. So 1 is done for you guys. Now you have to talk about whether the function is onto or not. Okay. Now how to prove that the function is onto? To prove that the function is onto, the second set, that means the y set, this set should be the range of your function. Okay. All right. Now, they have clearly mentioned what is y. So, you will get a natural number if you put x as a natural number, okay? So, basically, what I'm trying to say is, set y they are saying is y belongs to natural number such that y is equals to 4x plus 3. For some, that is the thing they are giving. For some x belongs to natural number. This is the definition of their capital Y set. Okay. Now, if I talk about the range of this function, how will you get the range, right? So, y is equals to 4x plus 3. If your x is a natural number in this equation, x is your natural number, this implies y will also be a natural number. Obviously, if you put x as 1, 2, 3, 4, these are natural numbers, right? You will get 4 plus 3, 7, 4 2 is 8 plus 3, 11. All the y will also be natural number. So, for some x belongs to natural number, y you are getting natural number. What does that mean? That means that range of this function is actually this only. Range is actually this only, right? This is what your range is. That's why the function is an onto function. Okay. All right. The function is 1 and onto. Now you have to write that, okay, final statement you have to give. Since the function is 1 and onto, hence it is invertible. So, if you write this, you will sure get 2 marks, because if you have showed that the function is invertible, you will get 2 marks. 1 mark for 1, 1 mark for onto. Okay. Now, find the inverse of f. If you solve this part, you will get 3 marks. Okay. Chalo. Let's do it. Okay. So, find the inverse of f. Now, we can easily find the inverse of f. How to find inverse of f? So, now f of x they are giving is equals to 4x plus 3. Or I can write y is equals to 4x plus 3. Now, what we are going to do is express x in terms of y. So, how will we do it? Y minus 3 equals to 4x. X equals to y minus 3 upon 4. And now what we need to do is, final step, we need to interchange x and y. That's how you find inverse of any function. Okay, so it is going to become what? Y equals to x minus 3 by 4, or you can say that this y will become g of x will be x minus 3 by 4. So here gx is inverse of f of x, right? Or you can simply write f inverse x is x minus 3 by 4, right? So if fx is 4x plus 3, your f inverse x will be x minus 3 by 4. That's how you solve this question. If you write this, you will get short 3 marks. Nobody can snatch any, like 0.5 marks also, nobody can deduct. Okay? Alright, I guess this is fine. This is absolutely good. Now let us talk about the next question. Okay? So what is the next question? Alright, so the next question will be from differentiability. Okay, so what is the question? I hope that you're able to see the question. I know there is some like visibility issue in this. So what I'll be doing is I'll be writing this question for you. So they are saying if y equals to 3 cos log x, if y equals to 3 cos log x plus 4 sin log x, and then what you have to do is show that x square y2 plus xy1 plus y equals to 0. This is what your question is trying to say. High probability that you will get such questions, similar pattern question in your midterm examination and in your main board examination as well. Here y2, please understand, I have taught you in another session which is most expected questions from continuity and differentiability. I have done one session like that, right? So y2 is double derivative, right? And y1 is single derivative. I will tell you, do not worry, okay? So what we will do is, this is your y differentiate. So basically, the whole question is all about differentiating the function twice. And in that video also I have mentioned, that first derivative, so you do it left, right, center, do not worry about it. First derivative without like applying any brains, just differentiate it. So dy by dx, I am doing it, equals to 3 cos log. So again, what we are going to do is, we are going to apply chain rule. So 3, derivative of cos is minus sine, log x will be as it is, and now derivative of log x, this is the chain rule, right? Derivative of log x is 1 upon x plus 4, derivative of sine is cos, log x as it is, and now derivative of log x is 1 by x. Okay, and this dy by dx is itself y1. This is the common notation. Dy by dx can be written down as y1 or y dash. Note that. Okay, so y1 is actually minus 3 sine log x plus 4 cos log x, correct, upon x, correct? Or what I can do is, I can just simply write whole upon x. Can I do that? This whole upon x. Yes. Perfect. Okay. Till now, I guess it is clear. Now, I have already told you, first derivative you do it. But in second derivative now, you have to slow down and you have to do necessary manipulations, right? So over here, x is here. If I again differentiate it right here, then on the right hand side, I will have to apply division rule. Now, applying division rule is not an easy task. You will agree, right? There is a formula. So rather than differentiating here itself, you have to just take this x towards left hand side. So this will be y1x equals to minus 3 sine log x plus 4 cos log x. Okay, and now there is no need of applying division rule. Also, here you have to write differentiating both sides with respect to x. Okay, just remember, you don't have to overdo with these steps, but you can't be underdoing the steps. Okay, write all the necessary steps. Okay, now again, now after this you will be differentiating both sides again with respect to x. Okay, all right, clear? Let's do it. Now y1x, on the left hand side we have to apply product rule. Now product rule is not a big issue, division rule is the issue. So y1x, so now y1 will be kept constant. This is how you apply product rule. Derivative of this x, tell me, derivative of x is 1. Plus, this time x is kept constant and derivative of y1 will be y2, my dear students. Equal to, now you have to differentiate the right hand side, minus 3 sine log x. So, minus 3 as it is, derivative of sine is what? Cos log x. Derivative of log x is what? 1 upon x. Now we have a plus sign, plus 4. Oops, I will not have space. I have to write a little bit. So y1 into 1 plus x y2. Better. Minus 3 cos log x. Derivative of log x is 1 by x. Now plus 4. Derivative of cos is minus sign. That's why minus sign log x, and derivative of log x is again x. Now what you have to do is again just shift this x on the left hand side. So y1x plus x square y2 will be equals to, if I take minus sign common, 3 cos log x plus 4 sine log x. Log x inside the bracket, and you're done. Right? Yes. Okay. On the right hand side, 3 cos log x plus 4 sine log x. Can you just see? We are exactly getting my original question. So, y1x plus x square y2 is equals to minus y. So, now if I compare x square y2, now just we have to rearrange. X square y2 plus x y1 plus y equals to 0, we are automatically getting. This is the beauty of such questions. Understand? The beauty of the question is you don't have to put an extra effort in proving it. Rather, you just focus on differentiation of the function twice and automatically you will get this. You don't have to put extra efforts on just putting the values of y2 and y1 and y here and then arranging. Usually. It might happen, sometimes you have to put effort, but usually it will not happen. But only if you are differentiating the second time mindfully. If at all you have not sent this x on the left hand side, then you will be like wasted. You will be like, oh my god, what is happening with me? Maths is not mathing for me. Okay, I hope that this is clear. Okay. And you know the ninja tip of the day, you have to solve this question and each and every question of this session in your notebook. Otherwise, you will not get that confidence. And remember, maths is all about confidence, right? Full marks you can get if you are confident enough. All right. Now, another similar type of question, again, there is a visibility issue. So, I have written the question for you that your y is a e raised to power mx plus b e raised to power nx. This is your y and we have to prove d2y by dx square minus m plus n dy by dx plus mn y is equals to 0. Now this time what we will do is, again, the first time derivative is mindlessly differentiate. Okay ma'am. So dy by dx will be what? Tell me. So so a is constant, derivative of e raised to power mx will be e raised to power mx, chain rule. Now you have to differentiate mx, derivative of mx is m, plus derivative of b e raised to power nx, derivative of nx is n. This is your first derivative. Okay. Now, again, now we have to differentiate it second time as per the question, and this time I am not getting anything. So basically, I am not doing any rearrangement. Even if I am applying my brains, what to shift, when to shift, I don't understand. Okay. So this is differentiating with respect to x. And this is differentiating again. This time no rearrangement. With respect to x again. Again written already. Okay. So now d2y by dx square. Remember how to write it. Understand, huh? You cannot just write this square, this 2 over here. This is the way to write it, okay? So that's why you have to solve it in your notebook to understand that what mistake you can do. Alright, now differentiate it one more time. Ma is constant, e raised to power mx, derivative is e raised to power mx. Now mx derivative, so one more m will come into the picture, so square. Similarly, nb is constant, e raised to power nx, derivative is e raised to power nx. Now nx derivative, you will get one more n, so I am applying a square. So this is part 2. Now unfortunately for this question, what you have to do is, you have to plug in the values, yes, right? So unlike previous question automatically you were getting this. But this time you have to prove that this is 0, so you have to plug in the values, okay? So this is the statement. Now put the values of, putting values of d2y by dx square and dy by dx and y from equation 1, let us assume this is 1, let us assume this is 2, this is 3. From equation 1, 2 and 3. Correct? Let us put the values. Let us see that whether we are getting right hand side 0 or not. Alright, so d2y by dx square. So this is m square a e raised to power mx plus n square b e raised to power nx. This is the value which we have put, minus m plus n. Now dy by dx. Dy by dx where? Okay. So ma e raised to power mx plus na e raised to power nx, correct? Plus m into n y. What is y? Ma'am, y is a e raised to power mx plus b, okay, space issue again, m n. A e raised to power mx plus b e raised to power nx. And this should be equals to, so this value we are calculating, we need to prove that this is 0, okay? Now, m square a e raised to power mx, as it is, I am just opening the bracket, m square a e raised to power mx plus n square b e raised to power nx minus m into m, multiply m square a e raised to power mx and then m into n plus, sorry, minus m square a e raised to power mx minus mn a e raised to power nx, then minus mn, sorry, this is b, right? Oops, plus nb e raised to power nx, correct? Okay, so this is your d2y by dx square, m plus n dy by dx plus mn this, okay? Alright, so now we are just multiplying m into m square, m into n b e raised to power nx. Now plus, sorry, minus it will be, minus mn a e raised to power mx and minus n square b e raised to power nx, and last but not the least, plus mn a e raised to power mx plus mn b e raised to power nx. This is what you're getting. Now understand. N square a e raised to power mx will get cancelled out by this. Gone. Don. N square b e raised to power nx will get cancelled out with n square b e raised to power nx. Okay, alright. Okay, so whenever you cut these things out, now do remember that, do it neatly, otherwise nobody will understand. Now what I'm doing is, I'm just making the color coding. White cancel, green cancel, right? Green, let me just, okay, I forgot to cancel this. These two, you will also understand when you will see the notes. Now, MNB minus MNB plus, these two also getting cancelled, and finally, these two are also getting cancelled out. Can you see? 0. Hence proved. Right? So, this is what your model is, where you have to differentiate the same function twice and prove a certain thing. Have a look. Let me know in the chat box, in the comment section, that whether you have understood this or not. In case you are having any doubt at any timestamp, you know the drill. You just write that timestamp. I'll be replying it to you. Okay, all right. Let us now move on to the next problem, which is from matrices. Now, we'll be doing just matrices, okay? All right. So, now A matrix is given to you 1, 2, 3, 3 minus 2, 1, 4, 2, 1. This is your A matrix and we have to show A cube minus 23A minus 40I is equals to 0 basically. This is what we need to show, okay? That this expression is becoming 0. Alright, clear? Any doubts in that? Alright, now how to prove? So we need to understand this. First of all, we need to calculate A cube. Once we have calculated A cube, we need to plug in the values of A cube, A and identity. Okay, A cube, A and identity. Cool? Let's do that. Okay. So what we will do is we will calculate first A square. We will multiply A with A. Once we get A square, then again we will multiply A in that A square so that we will get A cube. So basically the whole question we will spend a lot of time in calculation of A cube. This is the problem of matrix multiplication basically. So let's do that. Let's just only talk about A square. Okay. So A square, this is your A. A square will be A multiply A. Right? So I'll be writing the same A twice. This is also A, this is also A. If I multiply these two matrix, I will get A square. Right? So let's start multiplying. Okay? Let's do it. Let's do it. Okay. Alright. Now, how do you multiply two matrix? How do you multiply two matrix? I will show you. If you do not understand how do you multiply, I will tell you. But one tip that there are a lot of chances that while multiplying, you will make calculation mistake. So that's why whenever you multiply two matrix, especially 3 cross 3 matrix you are multiplying, always once you are done, cross check whether I have made any calculation mistake. Otherwise, you are doing your job but you are losing marks, right? That we do not want, okay? Because you are Ninja Ma'am student. So you have to score full marks on full in your any examination, okay? Right? This is your row 1, row number 1. This is row 1, row 2, row 3. Column 1, column 2, column 3. Again, this also row 1, row 2, row 3, column 1, column 2, column 3. Okay? Now, this is your row number 1. Row number 1 will get multiplied with column number 1. Okay? Row number 1, column number 1. How? Let me show you. So, row number 1 is this, column number 1 is this. So, this multiply this. 1 ones are 1. Then, so 1 ones are 1. 3 twos are 6. And 4 threes are 12. So, 1 plus 6 plus 12, you will get the very first element. Now, the second element. Row 1 into column 1. So, basically what you have to do is, row 1 is fixed, row 1, column 1. You have to write it over here. Row 1, column 2. You have to write it here. Row 1, column 3. You have to write it here. Okay, let's do it. So, row 1, column 1. 1 and then 12. Sorry, 1, then 6, then 12. Written over here, it will be 19. Okay, ma'am. Now, row 1 and column 2. So, it will be 2 minus 4 and plus 6. 2 minus 4 plus 6. Okay, this is your second element. Now, row number 1 and column number 3. So, this is going to be 3 plus 2 and plus 3. 3 plus 2 plus 3. Okay, so this is going to be 19. This is going to be 4 and this is going to be 8. Cool? Alright. Yes, this is how you are going to multiply matrix. So, row 1, column 1 here, row 1, column 2 here, row 1, column 3 here. Now, row 1 is done. We are done with row 1. Now, you have to pick row number 2. So, this is gone. This is gone. Now, row number 2. Now, row number 2 again, same thing you have to repeat. Row 2, column 1 here. So, 3 minus 9. Sorry, 3 minus 6. 3 minus 6. 3 minus 6 and plus 4. Row 2, column 1 here. row 2, column 2 here. So 3 2s are 6, minus plus 4 and plus 1 here. And then row 2, column 3 here. So it will be 3 3s are 9, minus 4 plus 1. Okay. So what you're going to get is 19, then 6 minus 2, 4, and then 8. Okay. So I have calculated this for you. 19, 4, 8. Okay. Then the previous slide. Okay, hold on. Yes, so this is minus 3 plus 4, it will be 1. Then it will be what? 6 plus 4, this will be 2, right? This and this. Yes, this is 2. So 6 plus 4 plus 2, 12. 12 you can see. And the last is 9 minus 4, 5 plus 1. Hold on. This, multiply this, you will get 3 minus 2 and 3 3s are 9 minus 2. 9 minus 2 plus 1. So this is going to become 8. And the last will be 4 2 1, 1 3 4. So 4 plus 6 plus 4, 14. Then row 3, column number 2. 4 2s are 8 minus 4 plus 2, 6. And this last but not the least, row 3, column 3. 4 3s are 12 plus 2 plus 1, 15. So this is what you're going to get is a square. This is your a square. Now, ma'am, what to do? Yes, it is a time consuming thing and you have to cross check also. High chances that you are going to make mistake in this calculation, okay? A square. Now, a square is with you. Now, what you need to do is a square multiply a. Okay? Majority time of this question is calculation of a cube only. A square into a. So, a square is, you know, 19, 4, 8, copy paste. 1, 12 and 8, 14, 6 and 15, correct? Multiplication with a. 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Now multiply again, same thing, row 1, column 1 here, okay. So I have done that for you, right. This is a3 is equals to a square multiply a, and this is how you're going to multiply a square a. So row 1, column 1, see 19 ones are 19, 4 3s are 12, 8 4s are 32. You are going to get 63. Row 1, column 2, 19 2s are 38, minus 8 plus 16, 46. Row 1, column 3, 19 3s are, then 4 1s are, 8 1s are here. So row 1, column 1, row 1, column 2, row 1, column 3. Okay, done. Now row 2. Row 2, column 1, row 2, column 2, row 2, column 3. Second thing you will get. And now row 3, column 1, row 3, column 2. Row 3, column 3, last row you will get. This is your a cube. Now that you have done the hard work, a cube is with you. Now the question becomes very easy. You have to just plug in the value of a cube minus 23a minus 40i. So I have done that for you as well. So this is going to be a cube minus 23a minus 40i. A cube, let us copy paste the value. We have already calculated a cube minus 23a. So minus 23a given already in the question, minus 40 identity matrix is equals to 0 is what we have to show. Okay. Alright, let's do it. Now 63, okay, so this is going to be 63, 46, 69 as it is. 69 minus 6, 23, 92, 46, 63. Let us solve these two, the remaining two out. 23, just tell me. 23, 46 and 69, correct? This is 369 minus 46, 23, correct. 4 3s are 12, 4 2s are 8, 9, 92 and then 46 and then 23. Minus 40, 40, 40, rest everything will be 0, 0, 0. Okay, now do it. Now do the math, okay. 63 minus 23, tell me, 40. 63 minus 23, 40, 40 minus 40, 0. So eventually what you are going to get is, the first row is, first element is 0. 46 minus 46 minus 0, 0 again. 69 minus 69 minus 0 again 0. First row is 0. Then 69 minus 69 minus 0, 0. Minus 6, okay. Minus 6 plus 46 minus 40. Minus 6 plus 46 Basically, it will be plus 40. Minus 40 again 0. So you will see 23 minus 23 0. Every term 92 minus 92 0. 46 minus 46 0. And then 63 minus 23 will be 40. 40 minus 40 0. So basically what you're going to get is a big fat 0. Happy 0. Right? So if you solve it, you will get 0. This is how you're going to get marks. Alright? Yes? Clear? I hope that this is clear to you. Okay, so now let us move on to the next problem. Okay, yes, so we'll be doing matrix, a lot of matrix in this session. Okay, all right, yes. Let us understand what this question is trying to say. So this question is trying to say A is given to you, B is also given to you, C is also given to you. 3 matrix, okay. Find A, B, C, comma A, B, C. Basically, they are asking us to prove the associative property of matrix that, okay, so what they are saying is calculate ABC and calculate ABC, right? And show that these two are equal. See, understand, in both the left hand side and right hand side, the order is not changing. A is coming first, then B, then C, and on the right hand side, A first, B second, C third. The order is not getting changed, but here you are doing BC first and then pre-multiplying A. Here you are doing AB first and then post-multiplying C. Okay. So let us start with the left hand side. Then same thing we have to do on right hand side. We need to match whether the final matrix which we are getting is same or not. Again, this is the question of matrix multiplication, and you know that matrix multiplication is something that can cause you lose marks. How? By doing calculation mistakes, so you have to be careful. Now this is A, B, C, your left hand side, right? Sorry, right hand side. This A, B, C. B, C we are doing. Okay, so in here, how to proceed? First of all, I want my BC to be at place, right? BC. Then what we will do is, we will pre-multiply your A matrix. So B and C. This is your B, this is your C. Okay. Now just tell me what is the order of this matrix. How many row? 1, 2, 3, ma'am. 3 row and 2 column. Okay. What about this? Ma'am, 1 and 2, 2 row and 1, 2, 3, 4, 4 columns. Okay. So the final matrix will be of the order 3 cross 2. Final matrix, BC matrix will be of the order 3 cross 2. Okay, let's solve for BC. How do you solve? 3 cross 2. So 3 rows and 2 columns. not 3 cross 2. 3 cross 4. So 3 rows, 1, 2, 3, column will be 4. 3 cross 4. 3 cross 4 will be the order of the final matrix. Understanding or not? This is how you calculate order. 3 cross 4. Okay. Now again, row 1, column 1. So 1 plus 6, you are going to get 7. Row 1, column 2. So 2 plus 0, 2. Row 1, column 3, 3 minus 6. Row 1, column 2. So this is minus 4 plus 3. Let me know whether you have got it or not. So row 1, column 1, 1 plus 6, 7. Row 1, column 2, 2 ones are 2, 3 into 0, total is 2. Row 1, column 3, so 3 minus 6. 3 minus 6 is minus 3. Row 1, last column, minus 4 plus 3. Minus 4 plus 3 is minus 1. This is how you are going to get is row number 1. Now, row 1 is done. Now, row 2. Row 2, column 2. So, this is 0 into 1, 2 2s are 4. 0 into 2, 2 into 0, again 0. This multiply this, so 0 and minus 4. This multiply this, last, so 2. Okay, and now the last, row 3, column 1, minus 1 plus 8, 7. This is minus 2, and this is minus 3 and minus 8, minus 11, and this is finally 4 plus 4, 8. This is your BC. Okay, that's how you calculate BC. Now, ma'am, what to do? Because we have calculated BC, now you have to pre-multiply A. Let me show you. I have done that for you, that as well. Okay, so this is what your BC is, right? BC is, let's check, yes, BC. Now BC, now but you want ABC, right? You want ABC, correct? So this is your ABC. Can you see? BC is this. This is your BC copy pasted. And this is your A, which is given in the problem. A and BC. Correct? This is your 3 cross 3. 3 rows, 3 columns. This is 3 rows, 4 columns, 3 cross 4. Final order of this ABC will be 3 cross 4. 3 rows, can you see 3 rows, 4 columns? Start doing it. Row 1, column 1 here. Row 2, column 2 here. Row 1, column 1 here. Row 1, column 2 here. Row 1, column 3 here. And row 1, column 4 here. Then pick row 2. Row 2 and column 1. 7 2s are 14, then 0, then 21, 35. So row 2, column 1 here. Row 2, column 2 here. Row 2, column 3 here. Oops. Hold on. I have deleted something. Yes. Row 2, column 3 here. Row 2, column 4 here. Done. Now row 3, column 1 here. Row 3, column 2 here. Row 3, column 3 here. Row 3, column 4 here. So here you get A, B, C. Cool? Are you doing it with me? Are you checking this thing with me? So now A, B, C. This thing is clear to you, right? Now in similar fashion, you have to calculate AB first and post multiply it with C. I will show you. This is the last step. The same thing. AB post multiply with C. So for that you need to calculate AB first. This is A, this is B. AB. Calculate the matrix multiplication. Row 1, column 1 here. Row 1, column 2 here. That's it. Now row 2, column 1 here. Row 2, column 2 here. Row 3, column 1 here. Row 3, column 3 here. Okay. So this is your AB. Now that you have AB, you want AB multiply C. AB is this, copy pasted as it is, and this is your C which is given in the question. Right? Now again you have to multiply these two matrices, and finally what you are going to get is AB, C. Now if you just check, this is your AB, then C, and this is your A, then BC. Can you see these two matrices are exactly same? 444 minus 7, 444 minus 7, 35 minus 2 minus 39, 22 as it is. 31, 2 minus 27, 11 as it is. So what we will write as the final here, ABC is equals to ABC, hence proved. After all the work we do, all we have to write is hence proved. Okay. Alright. And now last two questions of the session. Okay. And this is going to fetch you maximum marks in your upcoming, be it your midterm PUC examination or your, board examination. Okay. So in this question, solve the following system of linear equation by matrix method. Okay. So basically 3 equations are given to you. 3x minus 2y plus 3z equals to 8. 2x plus y minus z equals to 1. 4x minus 3y plus 2z equals to 4. These are the 3 equations. We have to get the value of x, y, z. But not by the normal method. No, you can't do that. You have to apply matrix method only, so that you will get the answers, right? So how do you tackle it? First of all, you have to understand that in matrix method, this is the equation that you have to create. You have to show that the whole question is written in the form of Ax equals to B. Now you must be wondering, ma'am, hold on. What is capital A? What is capital X? What is capital B? So basically these 3 things are 3 different matrices. I will show you. Here this A you are seeing will be a matrix which is formed by coefficients of the left hand side, coefficient of x, y and z. Let me show you. So this is your A, right? A will be a matrix 3 cross 3 which will contain coefficient of x, y and z 3, minus 2 and 3. This is your row number 1. 2, 1 and minus 1, row number 2, and then 4, minus 3 and 2, row number 3. Okay. So this is your A matrix. Are you getting it? Okay. A matrix. Ax equals to B. Ma'am, you told. What is x? What is B? Hold on. Now x is a vertical matrix. Okay. It is a column matrix. Understand? It is a column matrix. Single column. It is unknown matrix. Basically the variable matrix. So this is what you want. Ax equals to B. Mein you know A, you know B. You need to find capital X matrix, which is this unknown. X, Y and Z. And this is your B. B is nothing but again column matrix formed by constant of the equation 8, 1 and 4. 8, 1 and 4. And then you will have Ax equals to B. So basically if you multiply A and X, you will get the left hand side of the equation and B is absolutely right hand side. Okay. So first step, I guess this is clear. If you write it in this form, you will get short 1 marks just for this. Now the next step, you want to calculate X, right? So X will be A inverse B. X is A inverse B. So if you want to calculate X, you have to shift A on the other side. You have to take inverse. So X is A inverse B. Now you can calculate X. So X, if you want to calculate, what you need to do is A inverse will be multiplied with B. B matrix you know? Yes ma'am. But ma'am, what about A inverse? We know A, but we do not know A inverse. Yes. So in this whole question, we will spend most of our time in calculation of A inverse. That's it. So the whole question is just asking you to calculate A inverse. Now what is A inverse? What is the formula for A inverse? So A inverse is nothing but adjoint A upon determinant A. This is the formula. A inverse is adjoint A upon determinant A. To calculate A inverse, you need two things. Adjoint A, determinant A. Okay. Determinant A, so you can easily calculate, right? Determinant A, let's calculate. This is your, I would say this is your, so determinant A will be just, do not apply that matrix sign. This is 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. So yes, expanding along row 1. So this is going to be 3, 2 plus 3, 5 plus 2. So this is going to be 4 plus 4, 8. And then this is going to be 3 and minus 6 minus 4. Okay. So this is going to be 15 plus 16 minus this is going to be 30. Okay. So, oops, let me just check once. 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2. Hold on. 3, 2 minus 3. Sorry, this is 2 minus 3, right? 2 minus 3. Correct. Plus 2. This is 4 plus 4, 8. This is correct. And 3, 3 2s are minus 6, minus 4. Absolutely right. So yes, now we are having minus 3 plus 16 minus 30. So this is going to be 16 minus 33 and this is going to be finally minus 17. This is your determinant A. Determinant A value, I hope you know how to calculate, how to expand along row number 1. 3 you have to keep, then 2 minus 3. Plus 2, the middle will have positive sign. 2 2s are 4, minus minus plus 4. So 2, 4 plus 4, 8. Last, this is 3 minus 6 minus 4. If you solve it, minus 17. So this is sorted. Adjoint A. Ma'am, how do we calculate adjoint A? Adjoint A you will calculate by taking transpose of cofactor matrix. Okay, ma'am. Adjoint A. Hold on. Slowly, ma'am, slowly. Adjoint A, just write it down. Adjoint A you will get by taking transpose of cofactor matrix. Okay. That means, ma'am, you're saying first you have to calculate cofactor matrix and then take transpose of it. Yes. That's it, my dear students. So, cofactor matrix, how will you get? So easy peasy lemon squeezy. You have to understand that this is 3. So 3 you have to hide this and you have to hide this. And now you have to calculate determinant of this remaining portion, which is 2 minus 3. So minus 1. Okay. Okay, ma'am. If you say so. Oops. What did I do? Hold on. Minus 1 I'm getting, but I don't need to write here. Minus 1. Minus 1. Correct? Now you have to talk about minus 2, right? Basically what I'm saying is cofactor of this element. This is gone, this is gone. Remaining is this. 2 2s are 4 plus 4, 8. 8 you have to write, but you have to apply a negative sign over here. So you have to change the sign of this element. You haven't changed the sign of this element, but you have to change the sign of this element. Hold on. Do not lose patience. Now, you want to calculate cofactor of this? Hold on, let me tell you. This is gone, this is gone. Now, 3 2 minus 6 minus 4, right? Minus 6 minus 4, so minus 10. This time you will not change the sign. So, no change, change, no change, change, no change, change, no change. Like alternate you have to do this. Now, this time you have to change, but then first of all calculate. So, we'll hide this and this. Minus 4 plus 9. Minus 4 plus 9 is 5 with a change. Now, this and this. So, 3 2s are 6, minus 4 2s are 12. So, minus 6. Okay. So, in this manner, you will calculate all the cofactors. Minus 1, minus 8, 10, minus 5, minus 6, 1, minus 1, 9, 7. You can match the values. I have done that for you. This is your cofactor matrix. Now, you have to calculate adjoint, right? Just take transpose of it. How do you take transpose? Minus 1, 5, minus 5, minus 1 is in column 1. I have to write it in this manner. Minus 5, minus 1, minus 5, minus 1, minus 5, minus 1. Okay. Minus 8, minus 6. Oops. Not this. So, this I have written like this. Minus 8, minus 6 and 9 will be written like this. 10, 1 and 7 will be written like this. This is how you take transpose. Row and column transformation, whatever which is written vertically, you have to write it horizontally. Vertical to horizontal, vertical to horizontal. And then we have got your adjoint A. Now, what was the formula? Let me go back. What was the formula? The ma'am, formula was X is A inverse B, and this A inverse is nothing but adjoint A upon determinant A and then B. So, this is your adjoint A. Let us plug in all the values in the formula. So, your X will be what? Adjoint A upon determinant A. This is your adjoint A. This is upon determinant A. So, adjoint A upon determinant A into B. Right? Now, you have to solve this chaos. Okay, let's do that. Minus 1 by 17. Okay. Now, just these two last step and you'll be like, oh my God, we are getting the answer. So, row number 1, column number 1. Let's do the multiplication. Row 1, column 1. Minus 8, minus 5, minus 4. Minus 8, minus 5, minus 4 is minus 17, ma'am. Okay. So, this is your capital X. By the way, if I write, let me write it with different colors. Yes. Capital X is what? X, Y and Z. That is going to be minus 1 upon 17 and this and this. Minus 8, minus 5, minus 4. So, minus 17. Row 2 and column. 8 is a 64, minus 6, 36. So, this is going to give you minus 34, correct? Minus 64, minus 6, minus 70 and minus 70 plus 36. Minus 70 plus 36 is minus 34, right? Then last, minus 10, so minus 80 plus 1 and plus 28, that you are going to get 1, okay, 51 with a negative sign, yes, right? Now, can you see, minus minus is becoming cancelled, 17 by 17 is 1, 34 by 17 is 2 and 51 by 17 is 3. So your x is coming out as 1, y is coming out as 2, z is coming out as 3. This is your final answer. X equals to 1, comma, y equals to 2, comma, z equals to 3. And you're done. Full marks will be awarded to you. Okay. So in here, understand that what I have observed in my whole teaching experience, that you guys do some calculation mistake over here and your small x, small y, small z comes in random fractions. Sometimes it is fine, but I feel for your PUC midterm, your numbers will be like that it should give your final x1, y2, z3 as just like the whole numbers. Okay. And one more ninja tip of the day, that why don't you do one thing, because you're not sure that whether I have done any calculation mistake, just one silly mistake can cause you incorrect answer, right? What you can do is you can just check 1, 2, 3 is satisfying in any equation or not. So 3, you put x equals to 1. And this is for your check. You don't have to show it in your notebook. 2 into 2 plus 3 into 3 is equals to 8. Is it satisfying? 3 minus 4 plus 9, ma'am. So 9 plus 3. This is actually 9 minus 1, 8, ma'am. 8 equals to 8. So brilliant. Bingo. We are actually getting an answer which is satisfying the equation as well. Right, right, right. Okay. So we are done with this question as well. And here we are having the last question of this session. Okay. Are we ready for the last question? Yes, yes, yes. All right. Let's kill it. Let's do it. Similar type of question. In fact, I will say this question is easier than the previous question. Okay. Yes. So what they are saying is use the product to solve the system of equations this. Okay. Use the product. So they are, first of all, they are asking about product. So if I just multiply them, what will happen? Okay. And one more thing, that this product, what is the relation of these two matrices or the product of two matrices with this I would say system of equations. So one thing, I don't know if you are noticing or not, I don't know how many of you are having great observation skills, but I would like to get your attention over here. Can you just tell me that the coefficient of this first equation is 1 minus 1, 2. Actually, it is matching with this. Equation number 2, 0, 2 minus 3. Can you see that? And 3 minus 2, 4. Can you see that? So basically, this is your A matrix. Okay. This is your A matrix. Okay, ma'am. If you say so, let us assume this is your A. 1 minus 1, 2. 0, 2 minus 3. 3 minus 2, 4. Now, the second matrix, now product which they are giving. Let's talk about the product. You will be surprised at what is going to happen. So yes, this is first and this is second. Okay, 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4, minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. Multiply, product. I know you guys are like not happy about calculating the product, but you have to do it. Okay. Chalo, row number 1, column number 1. Tell me, ma'am, minus 2 plus 9 and, sorry, minus 2, minus 9 and 12. That means you're going to get 1. Row number 1, column number 2. 0, minus 2, plus 2. 0. Then row number 1, column number 3, 0. Row number 2, column number 1, 0, 18, minus 18, 0. Row 2, column 2, you will get 1. Okay. You don't have to multiply it. Let me tell you, every time you will see this question, you will get either. So basically, first you have to multiply. So these three elements will be same. That's what I'm trying to say. Okay. These three elements. This will be either 1 times identity matrix or 2 times 2i, 3i, 4i, right? But usually it will be some multiple of identity matrix. Okay. Alright. So what does that mean? The multiplication of 2 matrix. Okay. Multiplication of 2 matrix. If multiplication of, let me tell you, multiplication of two matrix is giving you what? Identity matrix. That means one matrix is inverse of the other matrix, my dear students. One matrix is inverse of the other. So if you are saying that this is A matrix, that means this will be A inverse. So you have clearly, so basically what they are doing is they are like spoon feeding you. They are ready-made. They are giving you ready-made thing. This is ready-made. A inverse you don't have to calculate. This is your A inverse. Minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2. And now what you have to do is understand. So AX equals to B. And X will be A inverse B. Right? Here your A, so you have already mentioned. Copy paste. Okay. X is again X, Y, Z. And B matrix will be constant matrix. Let me just 1, 1 and 2. So your X is A inverse B and X will be X, Y, Z. A inverse you know, B you know. 1, 1, 2. X inverse, let me go back. Minus 2, 0, 1. Okay, ma'am. Copy paste. 9, 2, minus 3. Okay. 6, 1 and minus 2. Okay. This is A inverse. This is B. Now you just have to multiply. Row 1, column 1. Minus 1, 0 and 2. Okay, you are getting 0. Then row 2, column 1. 9 plus 2, 11. 11 minus 6 is 5. Okay, ma'am. This and this. 6 plus 1, 7 minus 4. 3 is your X, Y, Z. X equals to 0, Y equals to 5, Z equals to 3 is what your final answer is. And you know that, right? 0, 5, 3 you will have to get satisfied to just check. So 0 minus 5 plus 6, 1. It will satisfy in every equation. Okay, alright. So we are done with the last question as well. And before you leave, hold on. Don't do that. Before you go, I have a special announcement to make. What is that announcement, ma'am? So before your midterm examination, also please let me know that when exactly is your mathematics paper, okay? So rather than commenting formula session, comment date of your midterm examination. Yes, date of maths paper of midterm examination. Just write midterm. So if your midterm is maths paper is on 23rd October, just write 23rd October in chat box in comment section. If at all it is having on 28th October, you write 28th. Please do not write others. Do not copy comment of others. Suppose you are having midterm on 28th and you are just writing 23rd. Don't do that, okay? Your maths paper examination, so that I can plan a complete midterm formula session, the last minute revision that you all need. Whole mathematics formula revision session I'm gonna take, okay? And you have to comment if you, in case you want that I take this, only then. Otherwise, if you don't want me to take formula session, do not write anything. But if you want, just write the date of your maths paper, correct date of your maths paper of your midterm examination. And you can, if you are having any doubts regarding your KCET, regarding your boards, regarding any academic, non-academic, any doubts you are having, okay, you can just ping me on my Telegram channel, t.me/Namrata Jaisinghani, Jay. Okay, alright. And I'm gonna see you in next video. And don't forget to like and share this session among your school friends. Bye bye. See you.